Okay, so this is the second problem we are going to discuss. Okay, this problem I was not able to make it. I was not able to do it initially. Okay, but no problem. I saw some hints somewhere, and let us see how to do it. Okay. So, what is the problem? We have two coaxial cylinders of same length L and radii. Radius of inner one is root 2r, radius of outer one is 2r, and some charge is given on the inner surface, and that charge is q, and the outer cylinder is grounded. So, obviously, outer cylinder will get some charge from the ground. Okay. The annular region means this region they are trying to say this region is has k is equal to 5. Here the k value is 5. K value is 5 means permittivity of this material, relative permittivity. Okay, relative permittivity of this material is 5. Okay, consider an imaginary plane of same length. So we are considering a imaginary plane of same length, and it is at a distance r. It is at a distance r from the center. Okay, so this distance is r. Okay, and they have also mentioned that this distance is root 2r. Okay, already written it here. Okay, this distance is root 2r. So clearly that angle, actually we will need this angle. So this is root 2r. Okay, now cross sectional view is shown here ignoring the edge effect. Ignoring the edge effect means electric field exists only between the cylinders. Okay, not outside. No fringing of electric field is there. Okay, so it has some positive charge, it has some negative charge. So this fringing we have to neglect. What we have to assume, the electrical field is radially outward and only in between the cylinders. Okay, and what we have to find, flux of electric field through the plane. Through what plane? This plane. This plane is infinite, but nobody is, because electric field is not everywhere. Okay, electric field is only between the these cylinders. Okay, now we have to find the electric field. So let me show you how the electric field will look like. Okay, electric field will actually be radial. Okay, radial means electric field will be like this, and electric field will be like this. Okay, and electric field will be like this. Electric field will be, okay, here I am doing like this. Okay, so basically electric field is radially outward. Okay, okay, and now we have to find the flux. Okay, so we have to find flux. Here see, flux is present only in this area. Okay, flux is only present is flux linked with this will be present here only. We have to focus on this part only. Okay, okay. Oh, yeah. So electric field is everywhere in between the cylinder, but we have to find flux passing through this line and this line only. Okay, so how can we do it? Total flux. What is the formula of total flux if the charge is q? We already know this thing. Okay, if charge is q, total flux is q by epsilon naught. But this is when there is no dielectric material. Right now we have a dielectric material. Bound charge is still q, but effective charge will be q by 5. Okay, and effective electric field everywhere will decrease by a factor 5. So instead of q by epsilon naught, I will write q by 5 epsilon naught, because kappa is, because this k is what, 5. Now this is the total electric field. Okay, now if you consider a region, if you consider how much area is there, let us talk about this area. Okay, let us talk about this area. And suppose this radius is some r. Okay, so total area is 2 pi r l. Total area is 2 pi r l. Okay, and we are concerned with this part of area only. Okay, we are concerned with this part of the area only and this part of the area only. Okay, we have a good news. This angle will be 45 degree. Okay, this angle will be 45 degree and this angle will be 60 degree. Okay, so I will call it theta 1 and I will call it theta 2. Cos theta 1, you can see that is r by root 2r. So theta 1 is pi by 4. Okay, this angle is what, pi by 4. And now what about cos theta 2? This is again this length is 2r, this length is 2r. Okay, and this length is r. So cos theta 2 is r divided by 2r. So theta 2 here is pi by 3. And this angle will be theta 2 minus theta 1, pi by 3 minus pi by 4, and that will become pi by 12. Okay, and similarly okay, so what will be that area? That area will be 2 pi RL pi by 12 divided by 2 pi. Okay, so how did I get it? I will explain. Total area of the cylinder is 2 pi RL, curved surface area only. Okay, and angle subtended is 2 pi. So area per unit angle is 2 pi RL by 2 pi, and area for angle pi by 12 is this. Okay, this 2 pi RL divided by 2 pi is area per unit angle. I multiplied angle by area per unit angle, so I get this thing. Okay, but area total I will not write. Okay, okay, so I will call here flux is equal to phi 1. Okay, and I will call flux here phi 2. Both phi 1 and phi 2 will be same, so let us find phi 1. Okay, so phi 1 by A divided by phi total by A total. Okay, we can see that flux is directly proportional to the area. If this is half area, it will take half of the flux. Full area, full flux. Okay, so I will write it here. Okay, phi 1 by total area was 2 pi RL, and this was how much? 1 by 24. Okay, 1 by 24. Okay, so basically this area is only 1 by 24 of the total area. Okay, and phi total by A total. Okay, A total is 2 pi RL. Okay, so here phi naught is sorry, phi 1. Phi 1 here is phi 1 here is phi total by phi total was phi total by 24, and phi 1 plus phi 2 will be phi total by 24 sorry 12. I mean we are adding it this thing twice. Okay, I am just multiplying it, doubling it. Okay, so this is what we are getting. Okay, and phi total was q by 5 epsilon naught, q by 5 epsilon naught. Okay, this is a good question and I had to see the hint. Okay, so we are getting q by 60 epsilon naught. Okay, q by 60 epsilon naught. So our answer is C. Okay, good.